Yeah, thank you very much for that nice presentation. Short about myself, I'm actually a flavor biotechnologist by nature. So coffee is not the topic I'm normally working on, so I'm more on the fermentative generation of flavors. However, I think 2 years ago, we had the chance to work on a project about coffee leaf tea. So where I first met Mr. Schwarz and also Mr. Lachenmeier, and since then we're always like, carrying out some small projects regarding aroma properties and sensorial evaluation of different coffee byproducts. So welcome to my talk. Today I'm going to talk about coffee leaves and coffee flowers. We already heard some of it yesterday. Why we should use coffee byproducts, what is coffee leaves, coffee flowers. So I'm just going to give you a very short introduction to them again, also from a legal aspect. Then I started showing our results about the project we did on coffee leaf tea we carried out in El Salvador. Then some short results from our current project on coffee leaves. And all the project or the results I'm going to present is a cooperation, between the University of Hohenheim, the CVUA in Karlsruhe, so our chemical food safety regulatory thing we have here in our state, and also the coffee consulate. So shortly about byproducts. So coffee industry is generating a wide range of byproducts from green coffee processing, or also from the coffee processing later. So you can see here on that side we have the coffee cherries, we have the twigs, the wood, cherry pulp, parchment skin, whatever. So we actually have a lot from the coffee processing itself. So if we look at the common byproducts, which are mainly known to also a wider public, we have the coffee grounds, we have coffee husks, also coffee cherry pulp, but there we already learned yesterday that some people still don't know that the coffee comes from a cherry, and also the coffee silver skin. And for this product, there's already quite some research going on how to use it. So we have some research on using it as biomass fuel because it's maybe not suitable for the feed or food applications. Especially for the cherry pulp, we have food applications like beverages producing out of the cherries. And also the coffee silver skin is currently in good research as a food additive, as dietary fiber. However, not so much research is done on the byproducts which are derived from non-bean products, so meaning from the coffee plant. And we have the coffee flowers and the coffee leaves, which I'm going to talk about today. And why is that interesting? Because it would also help the farmers to get some other sideline sources for their income. Because if we have a failure, for example, in the bean production, they basically has no income. But then they maybe will still be able to sell the coffee leaves. So we have a more sustainable way for the coffee products. Problem again here is we have novel food, so we also have to think about the application in a legal aspect. So when I talk about coffee leaves, I guess all of you know how a coffee plant looks like. We have green to dark green leaves. Depending on the species, they are bigger or smaller. And already in some coffee-producing countries, we have this traditional tea-based beverages made out of the dried coffee leaves. In literature, it's described that these coffee leaves have a similar flavor to green tea, but has a lower caffeine content and also show less bitterness, which is relevant when you think about where to sell your coffee, because I can tell you, we as Germans, we don't like that bitterness coming from green tea. So for us, a coffee or a tea with lower bitter compounds might be an interesting product. On the other hand, we have the coffee flowers, which normally bloom between March and May. Yeah, depending on the species, we have around about 30,000 to 40,000 flowers per tree per year, so actually quite a lot to harvest. And the good thing is that after pollination, we can harvest those flowers without risking the production of the beans. And the fresh flowers has an intensive smell, which is reminiscent of jasmine. And when you look at them, they also kind of look like jasmine flowers already. Yeah, and there we have a potential usage, for example, in a tea-like beverage as well. So coming to the regulatory stuff, I guess there will be another talk later, so I don't go into detail too much. Just a few sentences of coffee leaves. In Europe, you can use it. It's allowed as an infusion since 2020, so we have a novel food. However, at the moment, it's not permitted to blend it with other ingredients or use it in other beverages. So far, we only have the application in a tea beverage. Yeah, there are also some regulations for the bioactive compounds, like how much chlorogenic acid, caffeine, epigallocatechin we are allowed to have in, but I will come back to that in a minute. There are already some products available on the market. So, for example, you can get coffee leaf tea from India, for example. On the coffee flowers, we have the problem. The European Union says it's novel. However, so far, it's not permitted in the EU. Because here we don't have a traditional use in a third country. So there's no country known which is using coffee flowers already as a beverage. So the process to get it as a novel food will be a little more complex than before. Yeah, the problem they state at the moment is that there's basically no toxicological data available for these flowers. So they have some suggestions what might be a good limit for caffeine, for example, or for the trigonelline. But yeah, so far there's no company interested in applying a novel food. So currently you can buy coffee flowers, but currently they're used for decorative use. So only for decoration, not for consumption. Okay, so coming back to the coffee leaf tea. So in 2021, I think, so during Corona, we carried out that project where we wanted to see what's the influences of processing on the aroma of coffee leaf tea. So we had the chance, or my student, Mark, who was also here yesterday, had the chance to go to El Salvador to spend some time on a really nice farm. And there, he was there for some weeks between February and March. And he harvested a lot of coffee leaves and did different processing. So we had a look on two different varieties. So we checked the bourbon and the Pacamara. We watched at different leaf types. So is there an influence whether we use the young leaves, the old leaf, yellow leaves, or even the shooters? And then we also had different processing applied to the leaves we harvested. So we had whole leaves, we crushed the leaves, we rolled the leaves, we fermented leaves, wildly fermented with a starter culture, and also applied different drying methods. So here on the side you can see some of the processing we did. So when he came back to Germany, he had 24 different samples in his luggage. Which you can see here on the side. So you can see that we try to separate between the variety, different leaf types, different processings, how we dried them. So most of the samples were just air dried, but we have one sample which was dried in the oven and one sample which was roasted. So to this I will come back later. And here you also see that we did some fermentation, so either no fermentation. Then we had some samples where we used a wild fermentation, so just with the existing microbiota. Then we also applied some lactobacillus or some yeast fermentation. So what we did afterwards was the analysis of the non-volatile compounds, which was done by the CVOA, just to check if we're in the legal regulations. Then we did a sensorial evaluation of the teas, and so an aroma analysis by gas chromatography, mass spectrometry, olfactometry. Yeah, so for the non-volatile profiles, we applied several methods, NER, HPLC, photometric analysis. So, for example, we found different water contents in the samples, which were influenced by the leaf type and processing. So we saw that, for example, the younger leaves normally had a higher water content than the older leaves. Also in the essential oil content, we found influences regarding variety and drying. And for the ash content of the samples, they were basically the same. Next, we also analyzed the typical compounds like caffeine, catechins, especially the epigallocatechingalate and also the polyphenol content. And there again, you can see that we have some influences from variety, drying, processing. But it was not like a clear correlation that we say if we process like this, we get higher or lower. And when you have a check at the regulations, what we should achieve, you can see that, for example, for the caffeine, they told us we should have below 80 milligram per liter in the final beverage. And now if you check what we have as coffee contents in 100 gram dry matter, you actually would need a lot of tea in 1 liter to get to your 80 milligrams. What was interesting for us is that in the regulation, we have a limit for the epigallocatechingalate content. However, when we analyzed in all the samples, it was not detected at all. So, so sometimes you have to question what is in the regulations. We also had a check on the chlorogenic acid, also on the lactic acid and the acetic acid, and from the lactic acid we definitely saw that we have an influence from the fermentation, so only in the samples where we applied lactobacillus we actually could see lactic acid, and in all the other samples we could not. So coming now to the more interesting part, I would say. So we did some teas out of it, and then we did an overall liking from all 24 teas with a subsequent descriptive analysis. And here on the picture, you can already see that we got quite a lot of different teas out of our coffee leaves. So we had some teas which were very light in color, some which were quite dark. What they all had in common, it was quite like a brownish, reddish color. But already if you have a closer look on the different teas, so this is the tea we used, you can already see big difference in how the original tea looks like. So in the end, we chose 8 different teas, which were liked by the most of the panel. What I said before, we had one which was roasted, so that sample here. And you can see if you check the smell, it was popcorn, smoky roast aroma, and also from the taste, we got a very strong roast taste. And this sample actually was quite hugely discussed in the panel, because there were some people which were saying, oh, this is brilliant, and the other people were like, no, I don't like it at all. So, but from the others, we could agree that they are nice, so we could see that when you apply a fermentation, no matter with lactobacillus or in yeast, you get nice floral, sweetish, fruity impressions, whereas when you only have the pure tea, like this sample here, for example, you have more that floral, green, vegetal odor impressions. So you can be actually quite flexible in what you produce as a tea to make it suitable for your customers. So like I said, this sample quite controversially discussed. So next we did an aroma decoding using gas chromatography olfactometry. because we analyzed the teas itself, so not the leaves, but the teas, we had to do an enrichment step to get all the aroma out. And for that, we used the technique which is called direct immersion stir-bar sorptive extraction. And basically, you have this little thing here, which is around 1 centimeter long, and it's basically a magnet which is covered with a polymer. So on the outside here, you have this polymer, and you can just throw that small thing in your sample, like you see here, and then just stir it. And this small thing will extract and enrich all the aroma compounds from the tea, which we can later then analyze on our GC MSO. I think, yeah, GC was already introduced yesterday. We also heard a little about olfactometry, just to show you how it looks like. So this is actually how we do our analysis. So we just have one person sitting in front of our machine, smelling all the aroma compounds. And for us, this is important to detect whether the compounds are actually aroma active or not. Because just because it is a volatile doesn't mean that it's aroma active. So in the end, we were able to identify 68 different odor-active aroma compounds out of the 8 different teas, from which we have round about 50 identified so far. So this is just to show you how much compounds we identified. What we could see is, for example, we have the hexanal or the decanal, which gives us very strong green and grassy odor impressions, also some floral impressions, which we could basically detect in all of the 8 samples we analyzed. However, we also had compounds, for example, the class of the pyrazines, so nitrogen-containing aroma compounds, where we only were able to identify them in this roasted sample, which makes sense because pyrazines are generated during roasting. Here some more compounds. Also very important class we found are the ionones, which all give us flowery, honey, floral odor impressions. And here again, one compound we were only able to identify in the roasted sample. It's indole, which gives us a nutty, slightly smoky odor impression. So we could definitely see that our aroma compounds we identify correlate with the ones we have smelled in the sensory. So in the next step, we did a semi-quantification of 23 different compounds. And when we have a look on the concentrations, we see that definitely the benzyl alcohol, the 2,4-heptadienyl, and the 3-hexanol showed the highest abundance. All of these compounds give quite green and floral odor impressions. And what we could also see is that we only have these pyrazines present in the roasted samples. So we could not only just smell them in the roasted sample, also from the analytical detector, we could say they are only existing in the samples which we roasted. What again could we see from, for example, the 2 samples I labeled there is a yeast fermentation, so that you can also see that there's differences in the yeast fermentation. So for example, here when you compare the concentration of benzyl alcohol in one sample, it was quite high. However, in the other sample, it was not that high. So it's not also saying that if we apply yeast fermentation, we definitely get this and that compounds. It's very also dependent from what kind of leaf we use or how we processed it. So for all of you who are not too deep in aroma analytics, just with the concentration, it helps us nothing. You can't say because the concentration is high that we have a huge influence of that aroma compound. So for that, we need to calculate the so-called odor activity value, OAV. And this is the ratio of the concentration you found in your sample divided by the odor threshold of the compound. And because these odor thresholds are super different, so they can be in the lower ppb or ppt area, but they can also go up to 30 ppm. And only if you apply that OAV concept, you really see the influence of your aroma compounds to your overall aroma. So then we calculated all that OAVs for our samples, and we found basically only beta-ionone is the most important compound to our samples. So not the benzyl alcohol or the heptadiener we identified before, but from the autoactivity value, you can see it here clearly, beta-ionone plays the dominant role in our samples. However, we found that we sure have some variable shares on how important the beta-ionone is. So I just brought you 3 examples so you can see that the share of beta-ionone on the overall aroma can range between 40% and over 80%. But still, in all of the samples we analyzed, definitely the beta-ionone was the most important flavor compound to give us this floral, green, a little citrusy flavor impressions. So if you're now interested in it, all that data is published, so you can just check out our publication on that, where you have all the information inside you need. Okay, so coming now to the coffee flowers. So what we did, we analyzed 38 different dried coffee flowers, mainly from an Arabica cultivar from El Salvador, but we also had some cultivars from India or one commercial tea from Thailand. So here on the side you can see all the cultivars we analyzed. Our partners from the CVUA did a sensory analysis for all the teas, and later we did an aroma decoding in the dried flowers using gas chromatography mass spectrometry. So, yeah, you might not see a lot here. And just to give you some impressions, what we found. So we could see that we have very different odor impressions we get from the teas produced out of coffee flowers. And you can somehow cluster it a little bit. So you can see we have on the one side, we have some dried fruit aroma we were able to identify in some of the teas. We had a quite floral impression, like jasmine, chestnut flower, acacia flower. We also had the more hay-like, black tea-like flavors, and we got some group which were quite herbal, so like thyme or sage impressions. So what we got out of that sensory is that you can, again, just check what the consumers ask you, what their flavor is, or what the flavor they want to have. So you can definitely just choose the right flowers from the right cultivar to produce different teas to meet the consumer's preferences. Because definitely, from my experience working since 6 years in tea, probably in Germany, the samples with the dried flower, with the dried fruit and the flowers will definitely be much more liked than the one which give us black tea or hay impression. Just we're being used to having like this fruit teas and everything. But I guess that in probably other cultures you will have people which say, oh no, we really like that thyme or sage flavors there. So afterwards, like I said, we did aroma analysis. Just because of the pure amount of samples, we couldn't do GCO, unfortunately. So we did a pre-selection of 24 target compounds, which were the most abundant in the chromatograms, and analyzed those. Here you can see that already we have some different shape from the flowers, similar to we had from the teas. These were all just dried, so they were not processed at all, but you can already see that we have some differences in the flowers just from the cultivar. For this analysis, we used the Headspace BIMI technique with these flowers. I think you already heard it yesterday. So it's basically just like a fiber with a polymer, so we are able to extract our aroma compounds from the headspace. So if we have a look on the different samples, you can see At some points quite similar, at some points quite different. So for that, all that 24 aroma compounds we analyzed, they were, except the cinnamaldehyde, they were abundant in all of the samples, just in different shares. So only in the Liberica samples we were able to identify that cinnamaldehyde. But I think yesterday also we had some Liberica which has actually quite indeed that cinnamon impression from the flowers. So now it makes sense that we only can find it in the Liberica, but it seems like it's not really present in the Arabica ones. To go a little more in detail, I just picked 3 different teas. So if we have a look at those 2, so now you have to open your eyes a little. So now we're interested in the methyl salicylate. So this is that orange block here and up here. And you can see that definitely in these 2 samples, we have a high abundance of the methyl salicylate. And if we now check again our aroma impression we got from the sensory, we can see that especially in the Uva Porte Bio sample, it was the only sample where we had a huge jasmine aroma present in the sensory evaluation. So we definitely can link here our sensory results with the huge abundance of the methyl salicylate. Unfortunately for the other sample, which had a quite high share in methyl salicylate, we weren't able to get that jasmine, but however we got a huge acacia flower impression, and yeah, they're different, but they're going in the same direction from the sensory, so you can also say, okay, probably here we have more the acacia flower impression. The other sample I want to show is the Amarosa. So here you can see that was basically the one sample which was also quite different to all the others if you have a look here. And there, especially focusing on that green bar here, which is the sabinene, so a terpene, which gives us a woody and green odor. And here we could find that this Amarosa sample was the one which gave us a huge black tea impression in the sensory, which could fit with the high share of sabinene we found in the sample. So currently we're still on trying to correlate all the aroma compounds to the sensory results, but I just wanted to show you that 3, that it's kind of reasonable what we found in the sensory that we can explain with the chemical composition. So the first part, so especially the chemical characterization and sensorial evaluation, is already published. On the aroma compounds, we're still working at the moment. So yeah, coming to an end. So we can say coffee leaves and coffee flowers gives us a bioeconomic value for coffee, and it's a huge, or it's a good thing for the farmers because they can have a side chain to generate more money, or also can say, okay, we don't have good beans this year, but we still have the flowers we can sell. What we found is that both the leaves and the coffee flowers shows very interesting aroma profiles and are therefore potentially used in new tea-based beverages. What we can say is that fermentation increases fruity and sweetish aroma impressions. When we roast, we can get that roasted and popcorn-like aroma. I don't know who of you knows Genmaisha. It was very, very similar to that one. So it's for the ones who don't know, it's roasted rice tea, basically. So we were very, very similar here in that impression. And if you do a careful selection of process parameters and cultivars, you're able to open a very, very wide range of different flavors, so you can make it perfect for different markets. However, current novel food regulations limits the use of coffee leaves, and the coffee flowers still need novel food permission and more research. So yeah, still some drawbacks for that. So at that point, I just want to thank my department, Mark, who carried out all the studies on the coffee leaves, then our partners from the CVUA and the Coffee Consulate, and also Andres from El Salvador, who was so nice to let us harvest the tree and the leaves from his trees. So, thank you.
So, if there are questions, we just changed the optics of the walking microphones from yesterday to today.
Thank you, Stefan. By default, I have a focus on caffeine. Sorry for that. It appeared to me that it might be a problem in the tea, from the numbers you presented. Is it correct?
I mean, we had like, I don't know, 30 milligram per 100 gram of tea. And we had 80 milligram per liter in the final product. So if you have 30 milligram per 100 gram, you need to apply 300 grams of dry tea to 1 liter to get to the... Okay. Yeah, no problem.
You were trying to find a new way to decaffeinate something here. So. Yeah.
Maybe in Switzerland.
Yeah. They have a medium value in Switzerland, that's correct. No, anyway, a quick remark from my side, just because we saw the Aramosa and maybe our two friends here with a French background and aroma background and genetic background. The Aramosa is actually a hybrid that is half coming from the Racemosa, which beautifully to me explains why it's so different, also like the Liberica, but just as a quick remark. Any more questions?
I want just to try the advantage just to be the chairwoman, just to ask you. Well, first of all, thank you very much for the very clear presentation, a very nice presentation. I like it very much, this how you name it, this product as no being derivative. Mm-hmm. I would say no cherry derivative, but also I agree, because it's something that is apart and give you another opportunity. But talking about the legislation that we all are concerned about, how difficult it is to deal with, about the epicatechin, do you think that is something just to try just to catch the people with the fraud, because they can be adding tea, for green tea, for instance, because in my knowledge, what we have more there is the chlorogenic acid, and they say they have like a limit, because as you said, they can be roasted. The leaf that we are using, the one that we are using is the old one and roasted one, because we believe that in terms of safety, it may be better control. Yeah. But, and I'm not too clear if the legislation tells us if we need just to use exactly the old, and if we need just to use the roasting. Maybe you are better updated about that than me. But you don't think that this matter about the epicatechin could be a matter just to avoid the fraud, or, you know, the adulteration with the green tea?
Yeah. Yeah, I think that like that epigallocatechin come probably because they were thinking about green tea. So they didn't do any analytics before, because they stated, okay, we need to have that epigallocatechin inside. I mean, definitely it would make sense that it's maybe there, but maybe just the coffee tree or shrubs can't produce that epigallocatechin galat, but they can produce maybe the precursor. So maybe they analyze something of that and say, okay, we know that we have to do regulation on that epigallocatechin galat, because we know from the tea that it should be there.
We have more questions now in the audience? Okay, go ahead.
Hi. You said you received flowers from different countries, and I would like to know, did you dry the flowers in the same way, even if they came from Asia or from Southern America or Central America?
That you have to ask my colleagues, because I just received the dried flowers.
Okay, because I might be able to answer. I think with one exception, they all came from El Salvador, and they were all absolutely equally dried. And
and they were also harvested at the same time of the day?
Yes, yes.
Okay.
So Andres has a small plot of all these different varieties that we planted, and they were all harvested the same day within 1 hour time. Just there was 1 hour time maximum difference, and all dried in the same moment with triple cotton regulated van, so that there was a same air running. So we really try to be a little bit scientific correct.
Okay, sounds good. Thank you.
But again, the Indian we don't know. So that was a little bit reincarnated, but it was Liberica, so can be different.
Here we have another question on the right.
Thank you very much for a very nice lecture. A question about beta-ion. You found it in the leaves.
Yeah.
Did you check the carotenoid content of those leaves?
No.
It would be a good idea because
Yeah.
this would be the source of the
Yeah,
beta-ion.
definitely, yeah.
Yeah?
Yeah.
Thank you.
Any of here has another question?
Yeah, thank you for your great presentation. It's really what I would like to do with the cascara. Just for my curiosity, in Switzerland, when cascara was not yet accepted by the regulation, in a university or public institution, we were not able to do sensory analysis because the product was supposed to not be safe. So how were you able to perform a sensory analysis in a public institution with non-accepted on something that is supposed not to be safe in the EU?
Yeah, so with the coffee leaves, we did it in 2021, I think, so they were officially allowed in the EU, and we just did a very small sensory, so only like Mr. Schwarz, Mr. Lachenmeier, and the people who were involved in that project. So we didn't do a hedonic test yet, so like how the people really like it, but we just said, okay, it's on like your own matter, so we tell you this product, it's not allowed in the EU, so you can decide whether you want to join or not.
But all tests were carried out under medical and toxicological surveillance. So we were all there. So in that moment, it's legal.
And we all survived, so I guess.
More question? Very nice presentation. Thank you very much.
you.
And you have your present, of course.
Yay.